Hi there, my name is Krishal Latifzai. I am a physician at a clinic called Rocky Mountain Regenerative Medicine, and we are located in Boulder, Colorado. We specialize in stem cell therapy, and I wanted to take a few moments to tell you about what stem cells are and how they work. Stem cells are the primary healers in the body at the cellular level. And there are certain features about stem cells that really set them aside compared to other cells like neurons or muscle cells, bone cells, cartilage cells, etc. These other specialized cells. So when specialized cells, like those cells that I alluded to just now, when they reach full maturity, their ability to replicate and replenish their own numbers really begins to lack. And that capacity for regeneration declines. So if there is an injury, somebody tears a muscle, cartilage, etc., our ability to put things back together is really limited by this fact that these specialized cells are not going to be able to replenish their own numbers. And that's where stem cells, or one of the ways that stem cells are really different. They do have this ability to multiply and replenish their own numbers. The other way that specialized cells and stem cells are different is that specialized cells, like muscle cells, for instance, are not going to be able to turn into or give rise to other specialized cells like neurons. And neurons are not going to be able to give rise to cartilage cells, and cartilage cells are not going to be able to give rise to bone cells, et cetera. Again, that's a feature that's really unique to stem cells that makes them well positioned for healing and regeneration in that they are not just able to replenish their own numbers by replicating, but they also give rise to these specialized cells depending on what the specific context, what the specific situation is. So if there's an injury and what's needed are more cartilage cells, the stem cells are not going to be giving rise to neurons, even though they have that ability. And if there's a brain injury and stem cells arrive on scene, they're not going to be giving rise to cartilage cells in that setting. So those are the two features that really set stem cells aside from these other specialized cells and make them really uniquely positioned to do what they do really, really well, which is to serve this healer, this regenerator function at the cellular level. As far as how stem cells work, beyond just those two specific features, is that when there's an acute injury, be it a hypoxic brain injury, a spinal cord injury, a cartilage injury, a bone injury, somebody breaks a bone, those cells that are injured, they're going to be releasing chemical signals of injury that travel not only locally to that injury, but they also are going to be traveling to faraway places through the bloodstream, meaning if there's a good blood supply in that injured site, that the blood vessels are going to be able to pick up those signals. Those signals are going to be able to permeate into the blood vessels. They're going to be carried to far off places where we have stem cells in really high numbers beyond what's readily available in the close proximity. In close proximity to the index injury, to the initial injury, and in picking up those signals, the stem cells are going to start honing in on where that injury is, and again travel through the bloodstream to that injured site, and they're going to then come out of the bloodstream and follow the path of where these signals are coming from. And once the stem cells arrive on scene, there's some dialogue that happens between the stem cells as well as the cells that are injured. And so one of the questions for the stem cells is, are these cells that are injured, are they damaged beyond repair? And if that's the case, the stem cells direct those cells to undergo a process that we refer to as apoptosis, where basically those cells are killing themselves and weeding themselves out and making room for healthier cells to take their place. The next question is for these stem cells is, if there are cells that are salvageable, then what do those cells require? And sometimes it's components from the stem cells themselves, and sometimes it's other cells. It's help from other cells that also need to arrive on scene, and that's where again stem cells come in and they release certain chemical signals, both again locally and into the bloodstream to faraway places, calling on those other cells to arrive and lay down scar tissue or restore some level of function to the cells that are damaged. So that's how stem cells work. You'll note that a key component here, something that's largely unsaid, is that a good blood supply is really, really important. That's how these signals are conveyed to faraway places and attract stem cells to that injured site. And that's how stem cells, as well as other cell types, arrive to the scene of injury, to the scene of the accident, if you will. And so a rich blood supply is really not something to be taken for granted. In fact, as we get older, it's not a surprise that the areas of the body that are poorly perfused, that have a poor blood supply, are also the most vulnerable to injury. And that includes things like discs, as well as joints. And in a paradoxical fashion, it includes the brain and the spinal cord, because even though those areas, the brain and the spinal cord, have a really rich blood supply, unfortunately, there's this feature that we have called a blood-brain barrier that separates out the contents of blood vessels from the brain and the spinal cord. And the idea behind it is to keep pathogens, which are somewhat commonplace in the blood vessels, keep them at bay and not allow them to penetrate into a vulnerable area, a potentially vulnerable area like the brain and the spinal cord. And unfortunately, that same feature, the blood-brain barrier, is something that also keeps these stem cells at bay. And so that's one of the reasons why an injury to the brain or the spinal cord can be really long-lasting, and it can be something that's serious, that's difficult to repair, again, because of that poor traffic problem. By not being able to access those areas, stem cells are not going to be able to help regenerate the damaged tissue. And that's where stem cell therapy really comes in and is able to pick up the slack somewhat.